Let's take a look at parallel circuits here, and these are just a different way of arranging components. So if components are in parallel, they are in parallel, if the current must travel through either but not both elements. So it means it's only going through one or the other. So the most common example of this would be something like this. So as the current comes along, it splits and it has to go through one or the other, and then it rejoins together. And we know that it can't go through both because you can't have the current go like this and then come back around and come back to where we started without something increasing the voltage in this, because both these resistors will have a voltage drop. So it's like going downhill. So you can't go back uphill without a battery basically pushing it back up. So these are in parallel. You can get more elements in parallel just like this. And you can go as big as you want. Something that might look in parallel but isn't is, what would be a good example? What would be a good non-example here? Something that looks like it might be in parallel but isn't. Let me check my notes here because I think I have one. Well, we'll come up with ones later and we'll talk more about the difference between series and parallel, but for now, you've got those as examples, and of course you can build out as much as you want. You can also have it look a little bit wonkier, something like this. All three of these are in parallel because if you notice, it comes in and then it's got to pick one of those paths, and then it has to come out here. It can't go back up any of these paths because these are all voltage drops. They all have resistors, so it can't go along the wire and go backwards through the resistor. Okay, if you have resistors in parallel, the amount of current, or the total current, or the sum of the current through both or all must equal the total before the split. In other words, the total current has to equal the current through the first one, plus the current through the second, plus the current through the third, and however many you have. And this makes sense from that water analogy of if you have, your pipe splits into two paths, however much water is coming into the split has to equal the water flowing out in both directions when they add together. Because we're not making extra water, right? If we add these two together and get a bigger number, that means more water is somehow made in this split. If we get a smaller number, that means water is being lost in the split, and neither of those make sense. The equivalent resistance in this case is a little bit messier than it was with parallel, but you add the inverses together, and that equals the inverse of the equivalent resistance. So the inverses add together, you add all that up, and then you invert it one last time at the end. And the voltage drop across each resistor or across each path must be the same. In other words, we need to come back to the same height when we get to the when we rejoin. So if you think about the water example here, if I've got water flowing along and it splits into two paths, if I have a waterfall on one side and a waterfall on the other, and then they eventually come back together, then they only can come back together and rejoin if the change in heights are the same. So maybe there's a bunch of waterfalls in one and there's only one waterfall in the other. Either way, the voltage drop needs to be the same across each path that you could take. Because again, if we're thinking about like water and heights, they can only rejoin if they're at the same voltage. So let's look at an example. For each of the circuits below, the battery supplies a potential of 3 volts. What is the equivalent resistance of each circuit, and what's the total current in each circuit? So if we look at this, these actually are all the same circuit, even though it's a little hard to tell. So I'm going to redraw that first one. All I'm going to do is slide this wire down a little bit, and we're going to get something that looks like this. And then instead of having the wire come all the way down here and then pop out here, I'm just going to reattach it up here. And I get something that looks like this. So are you if you're comfortable with these representing the same thing as the first one, great. If you're a little uncomfortable with that, talk to me and we'll talk through it. But what we see here is as it comes out of the battery, it's going to go through either the top path, the middle path, or the bottom path. Either way, they all rejoin on the other side, and then it flows through in the same spot. If you look at the other ones, you also have the same idea. Either you can go through R1 and then rejoin eventually. You can go through R2 and rejoin, or you can go through R3 and rejoin. If you're not super comfortable with that, again, talk to me in class, and we'll kind of draw out all the paths that an electron could take, or all the paths that current could take, and we'll make it make sense for you. But it's something that if you see it, great, and we'll move on. If you don't, we'll take some time to go through it. In any case, we know that all 3 of these are the same, so we want to find the total current, which means we need the equivalent resistance, because our goal will be to replace it with just a single resistor, because then we can find the current in that circuit. So if we remember, 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So that's going to be 1/10 plus 1/25 plus 1/15. If you add all those together, do I have that already calculated for me? I do not. What's going to be our smallest? It's going to be hundreds. So 1 over RT is equal to 10 over 100 ohms plus 4 over 100 ohms plus, dang it, that does not go into 100. All right, I'll just do it on my calculator here. I was hoping to show that math, but this will go faster. So if you do that, you get 1 over RT is equal to 0.206 repeating. And then if we do that and we invert it, this is also equal to 31 over 150, by the way, which I'll just use here. So that means that RT is equal to 150 over 31. And then if we want to find the current, that's going to be V over R is equal to the current. So 3 volts, I put in my ohms there, 3 volts times 31 over 150 will equal 31 over 50 amps. And you could simplify that or rewrite that in different language if you want. This one is a bit trickier than series, so if you have questions, please feel free to ask and we'll go over things together.